Diane, should I log into Zoom using my personal account or the CNCF KubeVirt account?
Who is speaking? I don't recognize the voice. Sorry.
Hi, this is Chris Caligari.
Oh, yeah, probably with your regular one. Yeah.
Okay.
Yeah.
I'll be back in a second.
Okay. Hey, Roman. So Josh, I think we can hear you typing. There you go.
Interesting, because I didn't even think my mic was on, but
It comes in on default here in this one for some reason. Yeah. I've got my old pixelated image up there. That's
Hey, good morning.
good morning.
Good morning.
Hey, Elaine.
Hey, good morning.
Morning.
All right. I think we have everybody on the call. So. KubeVirt incubation presentation. Who will be presenting today?
right. Roman,
So,
you're up.
Can you hear me? Yeah, can you hear me?
Yep. Yeah.
Loud and clear.
Okay.
All right. Right. All right. Take it away. Thank you.
Are you sure you can hear me?
It's very faint, Roman.
Okay, wait, just give me a second.
Am I the only one seeing the
Black
black?
spot. It's a
Yeah.
black spot in the middle. Yeah.
Just see if maybe I'm on the wrong micro. I just verified it before, so it should have worked without issues right now. Stop sharing.
Oh, the black spot is your Zoom pop-up.
Yeah, that's just, yeah, but I just wonder if I'm on the wrong micro, if you can't hear me well. Can you hear me now well, or?
Yeah, you're sounding good now. Yes.
Okay, so let me share again, and we can start. And
The black
I
box
just,
is still
yeah,
there.
I just can't get fully rid of it, it seems, but I can make it small. Is it small now?
No, it's still in the middle of the whole thing.
It's
So
actually two boxes. So there's one way in the middle, and there's one tiny one on the right side.
Yeah, the
Yeah, they're
tiny one.
both, those are both the Zoom control boxes.
Yeah, how do it,
there's an X above. Hit the X. No,
which X? Sorry, but
no.
I have no X's here. This X is this X is from but that's from the Google presentation. That's not from
Yeah, I'm not quite sure what to say other than maybe go out and come back in again really quick.
yeah.
I was gonna say, or can someone else share the slides and you just tell them when to drive?
Yeah, that would be an option too. Let's do that.
Okay,
Chris,
Josh,
could you open it?
Yeah, I struggle with this every week with the community meeting. And luckily I'm on Mac and Zoom works well on Mac. Let me share.
Yeah, sorry for that. I didn't see that black box when I checked it with my phone before.
looks good.
And
They need to fix Zoom on Red Hat, maybe Red Hat Linux.
Yeah.
No, I mean, I was on my Linux machine and just logged in with phone 2 to verify. So I'm surprised that it doesn't work. But anyway, thanks for your patience. So yeah, I'm Roman Moore and I'm working on KubeVirt as one of the main maintainers since its beginning. And thanks, Chris, for going to the first slide now, please.
sure.
So first, before we go into the technical details, I just wanted to highlight again 2 main points, and that which can be summed up as we want with KubeVirt seamless integrations and everything. That means on one hand, we want that someone can just install KubeVirt. The only prerequisite is having KVM on the nodes, the kernel module, and you can just install KubeVirt and it does not modify your installation and just works seamlessly with the whole cluster, like with any container runtime implementation, with CNI, CSI, Malthus, and so forth. And this is for most parts of Kubernetes also true. There would be things like virtualized container runtimes, which would of course not work because that would be VMs and VMs and VMs and so on. That's not so much our business. And the other thing is, it's very important for us that the general workflows which are used to from Kubernetes also work for anything which we do. Like for instance, with our custom resources, you can use all kinds of generic Kubernetes features. Like a good example is the scale up resource. You can just define all the state of your VMs which you want normally with YAML, and can use your GitOps flow with, for instance, customize and so on. That's one aspect which is very important for us. And that's the next slide, please. Also, oh, that was one too much.
Did I go
One
one
back,
too
please.
far?
Yeah, one too, yeah.
Sorry.
But so this was before, this was the general idea on how we try to create the features. And now we want to go to the main part, and this is how we're actually doing the technical implementations, how our system looks like. And I think one key element here is that everything is very similar to the Kubernetes architecture itself. And I want to focus here on 2 main points to make this visible. And the first one is that our main workload, the virtual machine instance workload, is very similar to a pod and very related to a pod. And I want to show in a minute what I mean by that. And the other thing is that our control plane, so like our API services, controllers, node daemons, and so on, are also designed very similar to how this Kubernetes control plane looks like. Next slide, please. When you look at the virtual machine instance workload, that's our main custom resource. So the bottom, it has the same function for the virtualization world like the pod has for the container world. It's as a usual CRD, a completely normal CRD, metadata, spec, and status. And in the spec, you have all the definition of your virtual machine, but in addition, also a lot of the usual fields which you're supposed to know from a pod, like node selectors, resource requests, subdomain, host name, whatever, you can specify all kind of stuff there. And there are a few reasons why we are not just stuffing virtual machines directly into the pod and you express also everything with the pod. And they're mostly that while at the end everything is running inside a pod, there can exist more than one pod depending on what you're doing with the VM. Like if you're migrating a VM, you have one pod on node A and you want to migrate it to another pod on another node, and you can't express that with one pod. And this virtual machine instance gives us basically the fundamental base for creating all our controllers on top of it. By the way, just interrupt me anytime you have any question or want more details on some aspects. Next slide, please. If we look on how the Kubernetes components are structured and how the KubeVirt components are structured, you see here on this slide on the left side, you see the Kubernetes topology, and on the right side, the KubeVirt topology. And when we look at the first rows, which are about the host, you see that you have by Kubernetes the container runtime implementation, which could be CRI-O or Docker. And you have the kubelet, the node daemon. And for KubeVirt, it's very similar from the functionality. We have inside the pods, which are coming from the kubelet, our virt launcher main process, which also runs alongside with the VM inside a container. And we have our node daemon, virt handler. And I will explain later on a little bit more what the functionality is, but they have very similar roles. Yeah, and when we go up to the cluster level, there you have the controller manager and the API server on the Kubernetes side. And we have slightly different named our components, but with similar functionality, virt controller and virt API. And clients can normally interact very often with kubectl with the server, and it's similar for KubeVirt 2. You can have virtctl or kubectl virt for the KubeVirt specific extensions, and for the rest, like creating, updating, deleting, and so on, you can just use kubectl directly on our resources. Next slide, please. And here is then, I'm not so proud about this image which you're seeing here, but I just wanted to add it here too in this presentation because you will see it on a lot of places in the internet. So just that you can follow the diagram better, I wanted to explain it to you here too. When we begin it, and I want to just go with you through the creation of a VM flow. And when a user starts on the top left, which with a kubectl command to create a VM, it just goes to the normal Kubernetes API server, from there to virt API, where all validations and so on are happening. Then it's in etcd. From there, our controllers can see that a VMI was created and create a pod, which has the right shape for the VMI to be in there. Once the VM is running, once the pod is running on the node via the kubelet, our controller sees the two and can it over to our node daemon, which is virt handler, and virt handler can then instruct virt launcher in the started pod before how exactly the VM should be shaped like, and it can manage all the details of a VM, which basically boils down to that the pod is normally managed by the kubelet, and we are just injecting our bits there then. Next slide, please.
Roman,
Yeah.
One question about this slide. Does the virt CTL client interact directly with the API server, with the Kube API server, or with the virt controller or virt API?
So with
directly?
virtctl, yeah. So normally you just create with kubectl a virtual machine object or a virtual machine instance or a virtual machine instance replica set or whatever with the normal CRUD operations from kubectl. But once the VM is running, you have some unique operations which have no counterpart in kubectl. For instance, pausing a VM, accessing it via VNC or a console. Well, console, there is something similar with kubectl exec, but it's still slightly different. SSH access. For these, we have in our virt API server sub-resources, which are registered as an aggregated API server. And so virtctl can, so kubectl virt or virtctl can then directly talk to our virt API server there through the API server and forward that to the VM. Does that answer the question?
I see. Yeah, and then these components are for every Kubernetes main node. So you have like the control plane, you have a 3 or 5 or 7 nodes, right? So would you
Mhm.
have a Vert API and Vert controller for each one of them, or you have a just one,
So,
or just one
if you don't
DWC?
mind, I would want to answer these questions a few slides later because I think they are then all answered in the flow.
Great. Great. Sounds good. Thank you.
Okay, great. Then let's go on to the next slide. So here is here is the last component, which I didn't introduce before, and then that's our KubeVirt operator. And with the Virt operator, you can extend your Kubernetes cluster. It basically does the installation for KubeVirt. So you just, it's a three-step kubectl process. You first apply the operator deployment, then you apply with the second kubectl apply the KubeVirt configuration you want in our KubeVirt custom resource. It's a in this case, if you would directly execute the commands from here, it's a very simple one. There's basically just defaulting in there, which is normally good enough for a start. And then you, with the third kubectl command, you just wait until the operator has deployed everything, and you can see that on the available condition when it's done. The operator has a lot of additional tasks too. It does not just installation; it also performs zero downtime updates. It tries to self-heal the installation if, for instance, resources get deleted. It does all that with effective tracking of the resources, like with watches, work queues, and so on. And it also does some maintenance tasks, like cert rotations on. Once the operator has rolled out the components, they're in the cluster, and here we need the next slide. Talked briefly about Virt API before. Virt API is basically then just the entry point, which you have then deployed. It has a modifying webhooks for defaulting, validation webhooks for validation, and as I mentioned before, due to the great question, is that we also have sub-resources in addition to our custom resource definitions, and they are made available to an aggregated API server. Here we make a differentiation between the custom resources themselves, which we're just registering without an aggregated API server, and we just have the sub-resources exposed this way. This is a little bit better for us to not influence the whole cluster if something is wrong with our aggregated API server, like maybe blocking namespace deletion or so on. Next slide, please. Then when we go one step farther, we have the controllers which are all inside Virt controller. They also track the resources efficiently with watches, work queues, expectations, and all the stuff which you normally see in core Kubernetes controllers. And here I want to highlight that we're right now not using SDKs or anything, just because they're not yet giving us all the granularity to compete with the performance which the Kubernetes operators have. So therefore, we are really implementing them exactly like Kubernetes. And yeah, to sum up the main task of Virt controller, it's mostly responsible for managing or creating and managing the pod where VM will at the end run in. And also when you do migrations, it will create the new home pod for the VMs when the migration will happen. Next slide. And then we go to the node level where we have the Virt handler, which was the kubelet equivalent more or less. It's and this component is supposed to do all the privileged operations. Sorry, someone is opening a door to me. No, I stopped. Okay, sorry. So this Virt handler is supposed to do all the privileged operations on the nodes so that at the end we have pods which are completely sorry, my daughter just interrupted me. She will be gone in a second. So now I'm back. Yeah, so yeah, it does all the privileged operations, and it does them to free Virt launcher, which is running the VM from all privileges, so that once we're done with all the restructuring, where still some parts are going on, the Virt launcher pod is completely free of privileges and can really be owned by the user with the VM inside. yeah. Yeah, also it exposes device plugins for PCI pass-through. You can access, when you're accessing through Virt API, the sub-resources, they're then going from Virt API to Virt Handler, which is then orchestrating the access to the VM so that the network namespace for each VM is really completely free, just for network traffic for the VM, and we don't clutter it with administrative traffic. And it also tells the cluster about the VMI state like the kubelet does. Next slide, please. And this brings me to the last part here for our component, and that's Virt Launcher again. As said before, this is the component or the pod which really runs the VM. And for each VM in such a container, we have QEMU and libvirt running itself. The footprint is pretty small, although that may sound surprising at the beginning. So it's good enough to do it this way and helps us keeping the architecture simple. And our Virt Launcher in that pod is talking over gRPC and sockets to Virt Handler, and is supposed to run with complete non-root and without elevated privileges soon. And finally, apart from the socket communication, Virt Handler it itself has no access to the cluster API. Next slide. And here, I think I can now answer the questions regarding to how an installation will look like, regarding to failover and how often components are installed in the cluster. Here is what you would see when you install KubeVirt with the operator on a 3-node cluster. In the first 2 lines, you see 2 Virt API instances. That's our Virt API they're coming from our Virt API deployment. And Virt API is stateless. There's a service in front of it, and you can even scale it more up or down depending on your requirements for sub-resource access. There are no special considerations regarding to scaling. If one goes down, the other one can take over. Then you see that here there are 2 Virt controller pods. They're coming from the Virt controller deployment. Here we do the same thing like controller manager. We have leader election. So if one of them goes down, the other one can take over. If for a short period of time both are down, then the cluster operations are basically stuck for some time, but the workloads which are running are unaffected, and sooner or later one should come up again. Then you see 3 lines which are Virt Handler in this case. They are coming from our daemon set, which is supposed to install 1 node daemon on each node. Since it's a 3-node cluster, you see 3 here. There are no special considerations regarding to HA here. And except that they should restart on the node, which the daemon set is doing for us. And finally, you see the 2 instances of Virt operator, which are doing leader election too, like Virt controller, because they have their own controller loops. Next slide. When we now look at the actual virtual machine instances, for instance, here you see 3 virtual machine instances which were started by doing, and you can look at them via kubectl get VMIs. Then you can look at the pods in the same namespace, and you will see for each of these virtual machine instances 1 pod which belongs to it. That is so just to give you a brief understanding on how it would look like if you look at a cluster. Is that answering also the questions from before regarding to how the components are deployed?
Yeah, it does. Yeah.
Okay.
So essentially, they're deployed on the Kubernetes nodes. They're not deployed on the Kubernetes control plane. So.
Yeah, that's in theory possible. Like you could scale them automatically with master nodes if one chooses to, but right now it's just a normal deployment, which you can place on master or workload nodes, however you choose it.
Yeah.
So next slide, please. Yeah, so to sum up, I hope I've showed you a little bit on these architectural aspects that KubeVirt is structures very similar to Kubernetes itself, and that the virtual machine instance meaning is pretty similar to a pod, and that the control plane of KubeVirt is pretty similar to the Kubernetes control plane. And I think when keeping these 2 aspects in mind, it kind of unfolds itself from an architectural perspective and also code perspective, where to look for what and why specific parts are implemented at the location where they are. Next slide, please. Now if you like, I can now go on a little bit more about the two operations, how they're working, or we can, is it fine?
Yeah.
I think we still have time.
Yeah, we got, I think we
Yeah.
reserved an hour, so.
Okay, perfect. Yeah, I just want to give Chris enough time also. So for upgrades, I think one important day two operation are upgrades. The KubeVirt operator is designed to do zero downtime updates. And this is from an operator perspective pretty easy to do, but it still has to be orchestrated. So it will first update the node level. Once all node daemons are updated, the controllers are updated, and once they're all updated, the API pods are updated. And only when the new Virt API is online, new features can be used, which means we have a good rollout model to ensure that new features are only introduced to the lower components once all the lower components are updated to the new states. And so far, it seems to work pretty well. Next slide, please. As said before, I just summarized it here again. Apart from the zero downtime updates, we also have in the other components built-in mechanisms to be highly available. The Virt API server is stateless and can be scaled up or down as one wishes. Virt controller does leader election. And is from the principle, in principle, as effective as Kubernetes core controllers, but we are not using a gRPC, for instance, yet. Also, there are sometimes some minor regressions, like someone just implementing CRUD call, which you're missing in a review in the wrong place. But we're right now implementing with the help of 6Scale, which is driven by NVIDIA, to ensure that we have end-to-end testing to, apart from good code reviews, avoid that also on that level. The operator, yeah.
Question about when you do the upgrade, the Virt launcher basically stays up, and that constitutes a pod, right?
Yeah. So the workloads stay up, and our node daemon can handle all the Virt launchers quite to a pretty long extent in the past. But in addition to also bring virtual machines up to the actual new launcher, it's possible to define upgrade policies for the launcher pods too. And in principle, that's a migration update policy where you can tell the cluster that once an upgrade is done, it should over time migrate all virtual machines once. And with that upgrade, they get a new base. So that gets once migrated, and then they're on the newest Virt API. So you can, Virt launcher. And this way you can also migrate virtual machines if necessary to the new Virt launcher base without downtime.
Lina has raised her hand.
Yeah, I have a question, Roman, about the scaling for Virt API. What are the strategies that you offer? Is it like CPU memory based, or you expose some metrics that the operator can use?
Right now, you have to define it you have to define the scale on the operator. But it would be possible to add a status sub-resource. We would just have to do minor modifications on the operator to let that happen. Right now, it would reset it to the current defined number. So I have to say that when I talk here about that it can be scaled up or down to demand, that's more a potential architectural decision than that it's happening right now automatically. So I mean, you can say right now, give me 10 or 5 or 1, but it's not scaling up or down on demand with the status with the scale sub resource.
And if so, I understand it's manual. As an administrator, like how do I know that my Virt API needs scaling? Like when it's being slow, or what metrics?
We have another slide about metrics below them, but in general, we expose quite a big set on metrics. We expose the typical Golang metrics. We expose metrics for the Kubernetes REST client. the ones which also are exposed in Kubernetes. We expose the metrics for the watchers used, and we expose the metrics for the work queue. Yeah, but I mean, they're not all for Virt API. For Virt API, you have REST client, and you have Golang, and you have and you have for the REST calls going in, you have metrics how long they're taking.
Okay.
And that could be
All
And
right,
for-
I didn't mean to cut you off. I had another question.
Oh, just go on.
Yeah. So, in terms of when you do these upgrades, do you have a mechanism in the release process that checks whether if you change the API schema that it doesn't break the upgrades? Like
Yes.
for example, the Virt launcher may be using an old API schema, and Virt handler is using a newer API schema that has been changed, and potentially that could break, right? But is there a mechanism in testing and release that looks at that?
Yeah. So once we have, I mean, since it's gRPC based, we can use gRPC mechanisms for negotiation. But apart from that, we have in every pull request which you are doing on KubeVirt, we have upgrade tests, and they work like this: that the end-to-end tests on the pull request are installing the latest release of KubeVirt, creating a few different kinds of virtual machines. Then KubeVirt updates to the version of your PR, and then we do all kinds of checks to ensure that we can still normally communicate to the VM, and we also migrate it a few times. The virtual machines. Yeah.
Got it.
And
Thanks.
this way, I mean, it's not foolproof. There are always here and there are things where we have to do a bug fix, like on every project. But in general, I think the regression rate is very low in that area due to the automated testing. And maybe just because I didn't have anything on CI and CD in my slides, because I'm focusing on the architecture here. We have now a pretty huge set of end-to-end tests, and we all run them on every pull request. So when you do a pull request against KubeVirt, you're starting roughly, actually more than 1,000 virtual machines just for your pull request, and we spent quite some time on making that efficient. I think it pays off regarding to stability.
Got it. Thanks.
So if there are no more questions, then I go on. Where was it? Yeah, operator, I already said that it does lead election like the controller. Yeah, metrics and logging. Like hinted before, we have all kinds of different Prometheus metrics exposed. When you look at the workload metrics for our VMs themselves, every virtual machine, in addition to the pod metrics, exposes a big set of workload-specific metrics where you can really see CPU times inside the VM. You can see disk access performance, network performance, and so on, like you're used to on VMware or RHV. And for the infrastructure, we have a lot of metrics to identify bottlenecks, like are watches performing well? Is the work queue working well? Is the Kubernetes REST client okay? Like just recently, we had an issue on scale that our rate limiter inside the controllers was far too limited for bigger scale, and we were wondering for a moment, hey, why is it taking sometimes minutes to start the bulk of VMs? And then we realized, the metric just shows that the rate limiter got hit, and yeah, then you update the rate limiter bar, and you're good. Apart from also on logging, we have dashboards, 2 right now, not so much, but at least 2 dashboards in KubeVirt monitoring and runbooks. And also Kubernetes does on the operator level a little, KubeVirt does on the operator level a little bit to integrate us into well-known monitoring stacks. Like if you're installing sorry, I forgot the name. How's it called? There's this Prometheus operator for Kubernetes, and I think it's just Prometheus operator. And if it detects that the Prometheus operator CRDs are there in the cluster, we're auto-registering us. So you just roll out KubeVirt, and it creates the the monitoring service for the Prometheus operator, and you immediately get your metrics filled into your Prometheus instances. The same applies for OpenShift, which is also based on the Prometheus operator, but they have their own things. We also detect that, and it shows just up. We have also based on this detection, we have some alerts, like if Virt API or Virt control instances are all down, if there are only parts of them available for some time, stuff like this. And on the logging level, we are using a structured logger pretty long already, and it took me actually quite a little bit of effort to unify all the different logging sources to get one structured logging out of all the different sources. There's klog, glog, qem, and libvirt try to log to different places. And now we have klog v2 in Kubernetes, which I find pretty cool. We didn't have time to follow that move up yet, but I hope that this klog v2 can replace all our custom structured logic, custom structured logging logic. Now I have it. Okay, next slide. Yeah, that was it from my side. Are there more questions on the architecture? Maybe I missed some parts which you were expecting to hear more about.
Just one question, and you answered one of them. The KubeVirt uses aggregation, and it can potentially affect namespace removals if the KubeVirt components are down. Is that the only place that can affect the overall kube control planes?
Yeah. So first, the aggregated API server does not expose any resources, just the super resources, and this is extra to avoid that we would block such things. And second, that would be something which would have belonged to the first slide, where I set out some basic principles which we're following regarding to compatibility. We are working hard to never use required webhooks, for instance, on built-in types of Kubernetes. We have some required stuff for our own custom resources for validation and so on, but we also have some optional webhooks for evictions, for instance, and they're explicitly not required. And we have other workarounds to ensure that we're still consistent, just to ensure that we are not blocking Kubernetes operations when we are down. Because, and it's also possible and completely fine if KubeVirt is down and the cluster admin goes in and just wants to evacuate nodes, and he just starts deleting the pods as he's always used to. It doesn't matter if there is a VM in or not, they will behave correctly and everything will be fine, no matter if KubeVirt is healthy or not. And this is really how we try to be never in the way of core Kubernetes. And so far it worked out great. I'm not aware of any case where we are in the way, but it can also just be, we can just have been lucky so far that we didn't need to block it, but so far it should be good.
Thank you for the answer. Just one quick follow-up. So do you leverage finalizers on any of the core resources, or are you also trying to avoid it?
We have finalizers. That are one of the things which we need. So but we, wait, I just don't want to say anything which is still not correct. We have finalizers on our pods. So if KubeVirt is down, you would have to remove them by hand.
Thank you.
And what type of operations does the finalizers do? Are you aware of those, or somebody else?
Well, I should know it. Let me say it this way, since I implemented all this back then. I hate to.
Yeah, don't worry about it. I mean, it can actually be documented or something.
No, wait. I'm not sure. I think we avoided. We managed to avoid the finalizers then on the pod 2, and we just have it on the. Yeah, we don't have them. Sorry, no, I mean we don't have them on the pods. We just have finalizers on our VMIs. So this means that you can just delete pods, even if we're down, because we only have finalizers on our virtual machine instances, which are the base instance. And this is there to ensure that our virtual machine instance always lifts out the pod. So our controller ensures that when a pod is, when you're deleting a VMI, we are also deleting the pods where the VM is running in. But we want to ensure that the VMI just disappears when the pods are really gone. So we are delaying the final delete just to track the deletion stage and any errors which can occur during that, so that people and systems are informed of what's going on. But we're not using, and here I have to correct myself, we are not using finalizers on pods. So no core entities are any finalizers.
Okay. And is that documented somewhere? I would imagine yes, but yeah. So
it's mostly documented in tests so that it's ensured that it doesn't disappear. But this goes, so we do not have so much documentation on these very low levels. This is deep down in controllers, how they're performing the tasks. I did at least also not see documentation that low level for each control in Kubernetes. Maybe I'm wrong.
You know, I'm just putting myself in the shoes of an operator. Like, you know, why is my VM not going down, or why is the resource still showing up on my Kubernetes cluster or something like that, right? It's like, oh, I don't know what's going on. So like, you know, I would just Google, you know, like, do they have finalizers or something? Yeah. Anyways.
Yeah, it's a valid point. Yeah, and yeah, I think especially in the beginning when I started with Kubernetes, it would have helped me if that would have always been documented, that finalizers are used somewhere. Now it's kind of one of the first things you're looking at when the objects are not disappearing. Yeah, but it should be documented. Are there more questions?
Well, thank you, Roman.
Okay, yeah, thank you for your attention. Chris, maybe you want to take over?
Yeah, thanks, Roman.
And thanks again for moving the slides forward.
Yeah, not a problem. I'm Chris Caligari. I'm organizer for Project KubeVirt, and I'm here to talk about community health, particularly the community adoption and growth since Sandbox. Okay, our community structure, we're maintainer-led. We have a governance policy with a contribution ladder that guides us through 3 phases from a beginning contributor to a full KubeVirt member to maintainership. This governs several sub-projects for documentation, storage, testing, the Virt CTL client, Virt blocks, networking, UI, performance and scale. So KubeVirt's not, we really stress that KubeVirt is an ecosystem rather than a monolithic application. My duties as organizer is running the weekly community and developer meeting. We run a yearly summit where contributors and users have the chance to do formal presentations, and we also do event planning. KubeCon is our big bi-yearly event, but we also try to do other events such as vendor events and events like All Things Open and Supercomputing Con. Supercomputing Con's my favorite event. Okay, we have a list of maintainers. Roman is a maintainer. Fabian and Stu and David Vassal are longtime contributors, and I think they actually launched the project think Fabian actually launched a project. I'm a new maintainer, and we also have maintainers from SUSE and NVIDIA. And our latest maintainer is Ryan Hallisey with NVIDIA, who saw a need to create an additional SIG for performance and scaling out KubeVirt.
This is one question that comes up a lot in the TOC is the diversity of maintainers. So is there anything the project is actually doing to engage with other companies to increase the diversity of, not just make it Red Hat focused?
I reach out to non-Red Hat contributors on a weekly basis to ensure they maintain a presence with the project. It can be as simple as saying hi and would you guys like, would your contributors like some stickers or t-shirts, to how about becoming formal members or maintainers of one of the many repos that we manage. Ryan has decided to become a SIG leader, and that came about around end of May or June, I believe. That was set up. For community affairs, there's several contributors that are looking good to become maintainers. We have one from NEC that is looking good. She's holding off for a little while longer, but really trying not to press too hard, but I'm optimistic about that.
Got it. And do you actually reach out to some of the end users as well? Like in terms of, like, I mean, sometimes you find some maintainers that are interested in it. Yeah, so
I do. The contributors come and go like the tides. We have it's all based on their company workloads and whether or not they have a directive to be available. So we do get for the community affairs, we do get some non-Red Hat assistance, and it's
Also,
very appreciative, particularly with CI. We do CI on website and documentation, and so.
cool. Thank you.
also, if I may add here, for instance, Vasily from SUSE is also, he just did some contributions for a little while, and we tried to get in contact with him in Slack, and we actively were doing sessions to close gaps to make you a maintainer. So this is really something which we try to do. It's just, as Chris said, maintainers are contributions from people are coming in wave and going away when they're done sometimes. So it's
So you know, like I don't think this is a blocker for incubation, but it does actually come up a lot when projects go for graduation, right? So
We're going to see some a metric on how many companies are contributing to the project here shortly.
got it. Cool. Thanks.
Community project progress statistics since 2019, when we entered sandbox phase. We have 585 people from 111 companies have contributed to the project. including 301 pull request authors. We have 9 organizations on our referenced users list. This is something that I also press heavily on. So we have the virtualization channel on Slack has grown to over 1,000 members. KubeVirt has been forked 656 times on GitHub. And we've had 58 monthly releases since October of 2019. Community development, we have adopted a contributor ladder and a formal governance policy. We promoted 2 maintainers from additional companies, non-Red Hat companies. We held our first project-wide summit back in February, and that was a great success. Lots of good feedback from our survey. We have a design proposal process, and we have 2 major features have been run through that process since adoption. And we have improved responsiveness to pull requests and issues, as shown by metrics. Why is my keyboard not working? Why is my right arrow not working?
That's the,
I'm at
that's
end
the
of
last slide.
deck.
That's the last slide.
Sorry, I thought we had another slide for metrics graphs. But that concludes our slide deck.
All right.
Yeah, I
Well,
wasn't
thank you.
full screens. Thought we had a couple more slides there.
Well, thank you for the presentation. It's great. It's a good overview of the project. Yeah, I think, Alina, you probably got most of the information already, and I think you already started the due diligence document.
That's right. The Red Hat team is working on populating the answers to the questions in the DD doc, and it would be great to include the recording to this presentation in the DD for whoever is going to be reviewing to see.
Yeah, I'll go ahead and upload this recording as soon as it gets posted in the Zoom recording website, and I'll upload it to the CNCF TAG-Runtime YouTube channels, and I'll post it on the Slack channel. On we have a TAG-Runtime Slack channel.
Thank you.
Okay, I'm going to stop my screen share now.
All right. Any final comments, questions? Well,
Yeah.
thank you.
Okay.
Oh, go ahead. Sorry.
I just wanted to say, I think we have the document anyway, where we can also exchange questions, but also feel free to reach out on Slack if you have some questions which you just want to have answered or something. I don't know.
Yeah, for sure. Yeah, but we had the TAG-Runtime Slack channel in the CNCF workspace. So, so feel free to ask any questions, or if you have any comments or anything related to the due diligence document that may be missing, or that the KubeVirt team needs some clarification or something, they can also ask those questions there.
I've created that another channel just dedicated to KubeVirt DD, so we can just keep it. We can keep it there. I mean, the tag runtime is fine as well, but
yeah, either one works.
Thank you.
thank you.
Thanks. Have a great day.
Thank you.
Goodbye.